Dave Staublin here. We're going to talk about surface areas and volumes of similar solids. Now you'll see in the picture here that I have two blocks and they're dimensioned 213 and 426. And these are considered similar if all corresponding dimensions are proportional. So let's do that. Let's find out. So let's find corresponding sides. So this side and this side are corresponding. And so we can do a proportion, 2/4. And then we can ask ourselves, what's the ratio or the proportion of the next corresponding sides, which would be 1 and 2. And are those proportional to the remaining corresponding dimension, 3/6? And in fact, 2/4 is a half, which equals a half, and 3/6 is a half. So check. All the corresponding dimensions are proportional, so these two solids are similar. And this would be the similarity ratio. All right, so the next thing we want to do is we want to look at the ratio of the surface area of these two. Okay, you'll remember from the previous lesson on areas of figures that if the ratios were a/b, that the areas were a²/b². And we want to see if that applies when we do the surface area of a whole solid. So on something like this, there's actually 6 sides. And so let's calculate the area for the small and for the big. So there's going to be this side, which is 2/3, which is 6, and there are 2 of those sides, front and back, so 12. And then we have this side, which is area 1/3, and there are 2 of those, front and back. And then we have the top, which is 2/1, and there are 2 of those, top and bottom. So the surface area comes out to be 22. Now let's do the same thing for the big. Let's do the front side. So this is 4/6, which is 24, and there are 2 of those, front and back, so that's 48. And then we have this side, which is 2/6. So that's 12, and there's a front and a back, so there's 2 of those. And then we have the top, which is 4/2, and there's 2 of those, top and bottom. And so now we just have to add these up. Let's see, 18, 8, 9, 10, hold it, 6, 7, 8, so 88. Okay, so now let's see what this ratio is. So it would be 22/88. Let's see if we can simplify that fraction. 22 divided by 88, math fraction. Oh, it's the same as 1/4. Okay. Now, what I want you to, well, we'll come back and we'll compare the ratio of the sides to the ratio of the areas. Now, let's look at the ratio of the volumes. All right, for the small, the volume is going to be base times width times height. So 2 times 1 times 3, which is 6. And for the big, it's going to be base times width times height. So 4 times 2 times 6, which is 48. And the ratio of the volumes would be 6 over 48. I'm pretty sure that can be simplified. 6 divided by 48, math frac, is 1/8. Okay, so let's go on to another page and let's compare similarity ratio and surface area ratio and volume ratio. And for our example, the similarity ratio was 1/2, and the surface area was 1/4, and the volume ratio was 1/8. Now, here's what happens. If the similarity ratio is A over B, it turns out that if you take A squared over B squared, you get the surface area ratio, because 2 squared is 4. And if you do A cubed over B cubed, that's the volume ratio. 2 to the 3rd power is 8. So there are the relationships between similarity, between surface area, and between volume. Okay, so let's do an example. Let's say that we have 2 paint cans. We have a big and a small, and the areas of the big are 119 centimeters squared, and the small is 425 centimeters squared. And so that's the area. And then the volume of the small one is 1157 centimeters cubed. And that one is unknown. Okay, so let's see if we can figure this out. All right, so we know that the area ratio is 1019 over 425. And we know that the area ratio is A squared over B squared. So what we can do is we can take the square root and determine the A over B. So let's do that. So the square root of 1019 is 31.92, and the square root of 425 is 20.62. Now, if we want to find the area of, or the volume of the big one, what we can do is we can say, well, we know that A cubed over B cubed equals the volume over the volume. So the A value, here, let's do this, the similarity of the big one is 31.92, and this is 20.62. So we're going to take 31.92, and we're going to cube it, and we're going to take 20.62, and we're going to cube it. We know the volume of the small is 1157, and we need the volume of the big. Okay, so let's solve that. We can just do 1157, 1157, those cancel. And that x value, that volume of the big one, is going to be 1157 times 31.92 cubed divided by 20.62 cubed, and it comes out 4292, and the units would be centimeters cubed. And that's how it works. Check plus.